All right, ladies and gentlemen, today we're going to be talking about concentrations in terms of solutions. So we have a couple key terms. First one we're going to see is molarity. So molarity is equal to moles of solute over liters of solution. So we're going to write that out with our variables. We have capital M equals N, so moles of solute over liters, so capital L of solution. So I'll do this one in class together. We're going to go through this one here. So find the mass of copper 2 sulfate needed to make 250.0 milliliters of 0.7550 molar solution. So that capital M, we pronounce that molar. So we want to make sure that we don't start with the concentration. So if we're not starting with the concentration, what else do we have in the equation? Our volume. So 250.0 milliliters of solution over 1. Now we want solution is always going to be wanted in liters, solvent in kilograms, and solute in moles. Do we have our solution in liters? No, we have to convert it. So we use our conversion factor to get to liters, 1 liter over 1,000 milliliters. And then we can take our solution, so we have it in molar right now. So we know what molar is, moles of our solute over liters of our solution. So it's 0.7550 moles copper 2 sulfate over 1 liter of solution. So we can plug those units into our equation, make it easier for us to solve. Then we have to find the mass of copper 2 sulfate is what we're looking for from the problem. So we have to convert our moles to grams. We're going to do that just like we always do and use our periodic chart. Get 63.5 grams per mole times 1 for copper, 32 for sulfur, and 16 for oxygen. We have 4 of those oxygens, so we end up with a total molar weight of 159.5 grams per mole. We can plug that into our equation, making sure our units cancel out. Plug it into our calculator, we get 30.11. What are our units for this? Let's find out. So cross the milliliters out, cross the liters out, cross the moles out. We have grams of copper 2 sulfate. There's our final answer for that. The other term we're going to talk about today is molality. So spelled very similarly, means a little bit different. So molality is moles of solute, just like molarity, but instead of liters of solution, it has kilograms of solvent on the bottom. So we can have those units here. So our simplified, so little m is equal to N being moles of solute over kilogram, kg of solvent. So we'll solve this one together. So determine the molality of 58.212 grams of sodium bicarbonate, which I gave you the equation for NaHCO3 in 100.0 grams of water. We set up our mass that we're given over 1, trying to find out how many moles there are of that. So we need our solute in moles. So we use the molar mass, molar weight, just like we always do. Get 84 grams per mole of sodium bicarbonate. So we end up finding 0.69300 moles of sodium bicarbonate. And to find our molality, we need kilograms of solution on the bottom. So we have 100 grams of H2O. We need to convert that to kilograms. So we use that equation there. We get 0.1000 kilograms of H2O water. Plug that in, we get 6.930. Our units are going to be molality of NaHCO3, sodium bicarbonate. That's our answer. All right, we will do this together in class. And then we'll do these. So write those down. I'm going to go back because someone always misses this one before. So we'll get all those. All right. I'll see you in class. Take care.